Okay, so this is the CAD model for the Raman Spectrometer design. If I go ahead and hide the top of it, you can see the internals and where each individual component will be sitting. So here we have the laser module, which is the source of the light. It initially passes through a 532 nanometer bandpass filter to ensure that only the green light is entering the system, and then turns 90 degrees via a flat surface mirror. The light then travels through a beam cube splitter, and half that light goes towards the microscope objective lens, which focuses the light onto the sample, and the other half goes towards this beam dump, um, basically just a cone meant to reduce the reflection of light. And this was implemented because the system needs to be enclosed. We can't simply have just a hole for the beam to exit. And this is because the internal components need to be able to survive the harsh environments of a European environment. So after the light is focused on the sample, that reflected scattering comes back through the cube and towards the notch filter segment. Here, there will be either a 550 nanometer long pass filter or a 525 nanometer short pass filter, and these can be used to view both the Stokes and anti-Stokes Raman scattering. The light then travels through a slit to enter the spectrometer region, where there will be two identical mirrors used as collimating and focusing mirrors, and in the middle here, a diffraction grating on a rotating piece for orientation and calibration. And then the light is focused on the sensor, which will be mounted on a PCB, and this 3D printed piece will slide in and be connected to the microcontroller and the computer. As you can see, there are trapezoidal snap connections for each piece. A few test pieces were printed beforehand just to test the tolerance of certain things. But yeah, now let's get to the 3D printing. Okay, so this is the completed Raman spectrometer. Some of the top pieces are missing just to show some of the components. I have the tops on for the laser and the 90-degree surface mirror just because they're optically aligned with the shimming techniques with the paper. You can see an example of that here. So I'll go ahead and turn off the lights and demonstrate the laser. Okay, so safety glasses are on, lights are off, and the laser has been powered. So you can see the light coming through the cube beam splitter, some of it being reflected towards the beam dump, and the rest being focused through the microscope objective onto the sample, then being reflected back through the system through your slit, and reflected and focused onto the sensor. You can see on this piece of paper here, that's the slit. If I go ahead and just slightly move the diffraction grating, you can see the reflection moving, and that light is then picked up by our microcontroller, and the data is viewed on our laptop. This is the completed sensor. Right here we have the completed final PCB board with all the different parts soldered onto it, and the wires connecting it to the microcontroller. On the other side here, here's the linear CCD sensor that will be facing inwards of the spectrometer. This is our GUI that we use to visualize the data. So if I go on continuous collection here and enable this, so this is transmitting the intensity of light that it's experiencing, just the ambient light of this room right now. If I go on and turn on the light, you can see that the chart changes. I'll go ahead and turn back off. A little bit of drop in sensitivity. But yeah, there's the completed sensor.